Hello and welcome back to another episode of Math with Sohn. Today we're going to be looking at arithmetic sequences and series and writing the equations in explicit and as well as recursive form. So in order to do that, you first have to know the explicit formula is an equals a1 plus n minus 1 times d. Okay? That is the explicit formula. The recursive formula doesn't really have the same, it's not a formula, you make the formula. So the recursive would look more like this. So it typically is like an equals a sub n minus 1, and then if you're adding, it'd be plus d, but then you always have to have a starting point, and like you're going to have what is a1. So to be similar to this. Similar, and you don't need the parentheses. The parentheses are there to let you know that that's a separate thing from the difference. And as a reminder, the n stands for the term you are, like the number of the term you're looking for. D is difference, like adding and subtracting. A1 is your first term, and a sub n is any given term. All right, so let's get into it and show you the variety of ways that this can be done. For starters, let's get a series here, an arithmetic series. So I'm going to do 5, 7, 9, ... If you want to write the equation in explicit form, you are going to be missing some things, and that's okay because an equation has like an x and a y and things like that, so it's going to have missing variables that you don't plug in. But we do have our first term, a1, and we do know that this series is adding by 2. So the explicit formula would look like this. an, that's going to be an. a1 is 5 plus n minus 1. We do not know the n. This is an equation for any given term. So we write n minus 1. But I do know that we are adding by 2 every time. So my difference, my d, is 2. Now that is technically an answer. You could circle that and be right. However, most math teachers and even myself would agree that that's just a little too easy. So in most cases, you are going to be expected to distribute the 2 to both of these guys. And when you distribute the 2, you end up with 2n minus 2, which turns into a sub n equals 2n, 5, and negative 2 makes plus 3. And that, ladies and gentlemen, is the explicit version of this sequence for arithmetic sequences. The recursive formula is great. I tend to like them a little less, but they are great for like writing the equation because it's pretty easy. This a sub n minus 1 means the term before it, so that's going to stay there. That's just going to be there. The difference will need to be put in, and the a1 would need to be put in. So the recursive version of this formula is actually going to be even faster because you have an staying an minus 1 staying that way as well. What is the difference? I'm using the same thing over here. Well, the difference is 5 plus 2 makes 7 plus 2 makes 9, so the difference is 2. The big thing that a lot of people forget about is it is required when you're doing recursive formulas to plug in your a sub 1, and the a sub 1 would be 5, just like before. Because recursive is required to know where to begin. Okay, so if you haven't watched the recursive video, that might be a little weird, but make sure you go through and find all the other videos. I've been dividing them up for this category of arithmetic sequences, but recursive, you need to know where to begin. So the 5 would be the term, like if you want to find the next term, you would have to do 5 plus 2 to get 7, and then plus 2 to get 9, and then plus 2 to get 11, and so on and so forth. All right, so that's the main part. I'm going to continue with this video because a lot of times you're expected to take a recursive formula or an explicit formula and go back and forth between the two. So I'm going to do 2 examples of that. I'm going to go from recursive to explicit, and then I'm going to go from explicit to recursive and just show that you can go back and forth with that. All right, so let's say we had an explicit formula that said an equals 3n plus 5. Okay, so remember, this is explicit. if I want to go to recursive, if I want to get it to a recursive formula, I can get pretty gosh darn close because I know what my difference is. My difference is 3 because this is a line, ladies and gentlemen. This is y equals mx plus b. The slope is the difference. For anybody that hasn't told you that, the slope is the difference. So that means that my recursive formula, I can get pretty gosh darn close. I can get an equals an minus 1 plus 3 because I'm adding 3 every time. If it was negative 3, why don't we do negative 3? It would be plus negative 3. It doesn't change anything. Actually, you would probably just put minus 3. I don't want to do that. That's getting too messy. Let's go back to positive 3. Sorry. I apologize. All right. So, what is missing from the recursive? Your a sub 1. How do we find a sub 1? Well, lucky for us, the explicit formula is very easy to find any given term. If you wanted to find the 30th term, you could plug in 30. If you want to find the first term, you plug in 1. Well, what do we want to find? We want to find the first term. So what do we plug in? The number 1. So a sub n would equal 3 times 1 plus 5, which means our first term is equal to 3 times 1 plus 5, which is 8. And there we have it. And we have our recursive formula. All right. Now we're going to go from recursive back to explicit. So let's say I started with the recursive formula. And the recursive formula that I have is, let's say we got an equals a sub n minus 1 minus 5. So we have a negative difference, and the difference is negative 5. Where do we want this term to start? Let's say we started at 12. Why not? A sub 1 is 12. Okay? So in order to write the explicit formula, an equals a1 plus n minus 1 times the difference. We need our difference. We need our a1. And that is it. What is the difference? Negative 5. Great. Let's plug that in. What is the a sub 1? That's even easier. It's 12. As before, this is correct. That is a fully correct answer, but most of the time you're going to be expected to distribute. So an would equal 12 minus 5n, because that's negative 5 times n, and then plus 5, because that's negative 1 times negative 5. And then you combine like terms, you get an equals 12, and 5 makes 17. So that is our explicit version of the formula. Okay, so that's the majority. I do have a final secret for you to writing the explicit formula. Remember how I said this is a line, y equals mx plus b? All right, so this is a bonus problem. Let's say you had the numbers 5, 8, 11. We are adding by difference would be 3, right? Okay. I can write my an formula right off the bat without even using this guy. All right, I'll prove that it is the same afterwards. My difference is 3, which means my a sub 0, so to speak, would be 2. If we just backtracked a little bit, 5 is our a sub 1, but the 0th term, or the y-intercept, is 2. And you could write y equals, you don't have to write a sub n, y equals, difference is 3, we're adding 3 every time, 3x plus 2, which is the same thing as an equals 3n plus 2. If we used our fancy formula, an equals a1 n minus 1 times d, if we use that instead, if we were to plug in the a1, 5, and plug in the n, well, we don't know the n, excuse me. If we plugged in the difference, which is 3, if we did the math there, guess what we end up with? 5 plus 3n minus 3, distributing the 3. And what's 5 minus 3? 2. It's the same formulas you've been learning for a very long time. It's just presented in a different way. All right? So that was a bonus problem. But that's going to do it for this episode. Until next time, I want everybody to stay positive as always, and I will see you later.